Hello and welcome. So, first off, we have ourselves a circle, chord, and parts radii there. So, let's look at what we are given specifically and what we know from what we are given. So, first thing that draws my attention is this right angle right here. Whenever you have anything, any kind of line segment or radius or anything coming from the center of the circle and moving out, right, then when it intersects at a right angle, that point right there, that intersection point, is what we call the midpoint, meaning that the length from K to that midpoint is the same distance from that midpoint to E. So if that was like 7, that's 7, right? They're always going to be the same length. But what we're also given, in addition to that right angle, is that we're given that this entire chord length, right, chord meaning just a line inside of a circle, right, that chord is running from K to E and has a length of 4.8. Well, that means that if we were to split 4.8 evenly, we would have the same thing on both sides. Well, that would be 2.4, right, because 4.8, half of that is 2.4. That means that we have one distance is 2.4 and so is the other distance. Bam. Okay, and now we're practically rolling in gold here, because one more thing that we're given right here is this 2.8. Well, 2.8 is a radius, and how we know it's a radius is that we're going from the center of a circle to the circumference, right? So that means that anywhere you draw a line that extends from your center to the outside, that'll be that same value. That'll be 2.8. And that happens everywhere you draw that 2.8, right? That's another radius, 2.8. If we were to draw a line from B to K, that's also 2.8. Now, the reason why we want to do that is because now, what does that form? A right triangle, right? Right triangles are the bread and butter of these problems, right? We're looking at this when it's all right. So if we have a right triangle, remember for any right triangle that you have with legs A and B with hypotenuse C, you have something called the Pythagorean theorem, where we take leg squared plus leg squared equals hypotenuse squared. Okay, and we have those values, right? We have one leg that's 2.4, so 2.4 squared, plus our other leg, x, what we're solving for, wink wink, okay, squared equals your hypotenuse, 2.8 squared, right? And now you have an equation, you have a relationship set up, and you can solve for x, right? So all we do, finish solving, right? So 2.4 squared. So squared just means you have the same value multiplied twice. So 2.4 times 2.4, and that'll be 5.76. Plus x squared equals, and then 2.8 squared, which is going to be 7.84, I believe. Okay, so we have 5.76 plus x squared equals 7.84. Now, if your goal is to solve for x squared, you want to get it alone, right? Which right now you have a 5.76 on that same side, so we want to subtract it to move it over. Okay, so those are gone, and you're left with x squared equals 7.84. Whoops. So 7.84 minus 5.76. And when we do that, we end up with the illustrious, my absolute favorite number. Just kidding, it's not. 5 is my favorite number, but 2.08 is just as good. Okay, so we have x squared equals 2.08. Now, at this point, you're almost done, right? Your goal is to solve for x, not x squared, right? So how do we undo a square? Square root. And we end up with x equals plus or minus the square root of 2.08. Because remember, whenever you take a square root, there's plus or minus. Now, keep in mind, though, you're solving for a distance, right? A length. Is it possible for lengths to be negative? No, right? Wherever you're sitting, look across the room, right? Look somewhere else. You're looking a positive distance. There's no such thing as a negative distance because there's no such thing as directionality with distance. Velocity and a few other things there are, but with straight distance, you will always have that be positive. So that means you're just looking at the square root of 2.08. Now, our answer here is going to be rounded to the third decimal place if we need to. So at point, grab yourself square root. Right? Any calculator that can handle a square root, you want to be able to grab it, right? 2.08, put it in a square root in a calculator, and we end up with 1.442. All right, for rounding to the third decimal place, look to the fourth digit. That fourth digit is a 2, right? 1.4422, and that fourth 2 is going to round down, which means it'll be 1.442 final. 1.442. There you go. And that is correct, right? You solve for your missing distance, you're good to go. All right, so Pythagorean theorem, try to get to that. That is your bread and butter for these problems. All right, thanks for watching.